All right, in this video, we are going to talk about nonlinear systems of equations. Um, that's a really broad stroke, though. It, I'm not. That's painting way too many things. We're really going to talk about this right here: a system with a linear and a quadratic equation. Right. So in this video, I'm just going to briefly discuss what that all means. Okay, so hit undo too many times. Anyway. So let's answer that question. What is a nonlinear system of equations? Well, basically, it's a system of equations that involves uh, nonlinear equations, right? And well, I circled this for a reason. This right here, we've got a linear equation, but we also have a nonlinear equation, right? So obviously, this system would be nonlinear. It's nonlinear because this guy here forms a parabola. So if I drew a picture of it, right, y equals x, look like this. And y equals x squared minus 2, let's say negative 2 is here, would look like this. Right, and then you see we would have 2 points of intersection, right, which sets us apart big time from linear systems, right? So if I had a linear system, so let me do that in a different color. If I had a linear system, right, let's say, this was some function, let's call this f, and this was another linear function, we call that g, they would only have 1 point of intersection, meaning they would only have one set of solutions, right? X by y would be that solution. Well, here, on the other hand, we would have 2 solutions, right? So this would be one solution, x1, y1. This would be another solution, x2, y2, right? So how could we find the solutions? Well, the points of intersection, right? Or you could also do algebra to find where these points of intersection happen, right? And there's not always going to be 2. It just depends on the nature of the system. Sometimes it may be 1, just like on a linear system, right? But technically, if we're looking at, a quadratic paired with a linear function, there's always going to be 2 solutions just because it's, quadratic. Even if they don't intersect at all, they would just be non-real, right? So, yeah, that does it for this video. That's just the nature of what we're about to see. Obviously, in the next few videos, I'm going to go into a lot more detail. But if you have any questions over this, you know where to find me. Goodbye.